Okay, let's look at these questions. The sketch below shows the graph of f of x sine ax, g of x cos x plus theta for the interval x element of negative 182 to 180. Okay, now these are the two graphs. Let's look at the first question, 4.1. Determine the period of f of x is equals to sine ax. Now let's check this graph. We'll give the graph of course. Remember that the period is the way the graph completes the circle. Now, if you start here, we can see that this is where the graph starts to increase. It goes all the way and turns and goes all the way and turns again. Then here, it started to increase again till 10 and 10. So this from negative 1 to 0. So in other words, our period is what? Is 180 degrees. That is 4.1. Then 4.2, the second, write down the range of g of x. So we know that our g of x is given by cos x plus theta. In this case, now at a, this is amplitude here. So the range is always y element of, we can even use the amplitudes to say you have to be the negative of amplitude to the positive of amplitude. Or we look at the maximum value and the minimum value. Anyway, we can work on it, or we can even say negative 1 less equals to y less equals to 1. That's then now this write down the value of theta and a. 4.3, the theta. Now how do we get this? What do we know? We know that this a affects the what? The period. Now look at the original period of a core of a sine graph. We know that is 360. So we divide it by a. We have to get the period of the graph that we have here. In this case, we have what? 180. By inspection, we can see that if you divide this by 2, so our a is 2. To get theta, let's check how the graph shifted. Look at the given coordinate. We give it the coordinate a, negative 40 at 1. So let's go and check where do we find cos 1. And if we get cos 1 on the original graph, we're going to bring it back here. So let's consider this g of x was just what? Cos theta. So we know that cos 0 will give us 1. So now if cos 0 is 1, now where is that 1? Cos negative 40. It is cos 1 in this case. So the graph shifted from 0 to negative 40. So now that means it's negative on the graph, is positive on the equation. So now then g of x is equals to cos x plus 40. So now our theta, it is equals to 40. That's how we can do theta. Determine the value of g of 180. 4.4, g of 180. We know this case we're just going to have what? Cos 180 plus 40, which in this case we have it as negative 0,7. That's our value. Then 4.5, the same for which values of x in the interval 0 to negative 180 for which f minus g greater than 0. Now looking at this, f of x minus g of x is greater than 0. The 0 means positive. So if it's positive, that means that g should be above and f should be above, g should be below. So let's go and check within which interval, from 0 to 180. That's what we're looking at, where f is above g. Let's start now. Here is where they are equal. At this part, they are equal. So none of the graph is above the other. So here it's where they are equal. Here they are equal. So we don't looking for where they are equal, or looking for where one is above the other. So let's start from here to here. We can see that g is above f. So this portion is also included. We look from this part. We can see that from here, from negative 90 to 180. G is above. So what do? We'll say that negative 180 is less or equals to x less than 90. So the question might be, why include the negative in this case? Why are we including this? Because this is exactly where it's above. But here we cannot include this because here they are equal. But here they are above. So this is part of the answer. That's why I'm writing this. Or we can write it to say our x is the element of negative 180 to negative 90. Negative 90. Then now 5.3, 5.4.2, 4.5.2, it says g of x times of x greater equals to 0. So it's g of x times f of x greater equals to 0. Now, in this case, if like this, because they're giving us positive, if you want to see a positive answer, all of them should be below x-axis, or all of them should be above x-axis. So let's go and check where are they below all of them, or where are they above all of them. In this case, we should look at the intercepts, x-intercepts, because that's where they change, being above and being below. In this case, so raise how we answering the previous question, so that we can look at this question. Okay, now we'll mark where all of them are at 0. They are giving us 0 here, we're getting 0 here, we're getting 0, because it's where we have a 0, so we get 0 here. On this side, one is above, one is below, so it doesn't qualify. On this side, remember, starting from here going this way, one is above, one is below, doesn't qualify. But in between these, we can see that all of them are above. So what do we do? Because we see this, we can go to 135 less or equals to x less or equals to the other point of view, the other x-intercepts, negative 90 degrees. That's what we are doing here. Or we can even write x element of negative 1.5 to negative 90. That's good, that part. So 4.6, determine the value, minimum value of this. So it's given 3 cos 90 minus 2x. You must know that this can happen after shifting or after reflection, whatever, but on the graph. So look at this, cos 90 minus, it's on the first quadrant, where cos is positive because of 90, cos becomes negative. So now sine 2x is the graph that we have. So let's go and pick the minimum value on the graph of f. Minimum value on the graph of f, it's here, which is negative. So this, it will be minimum where the graph is minimum. So it will be minimum at 1 over 3.